will present for about 30 minutes, and then we'll have time for comments, discussions, and questions. But of course, if you have any questions or anything that it is not clear while I'm presenting, just let me know. Okay, so today, as planned, I will present on AI-related risk from an epistemological analysis. So epistemology is that part of philosophy that deals with the knowledge, how we achieve knowledge, what is knowledge, how we can make knowledge stronger, and so on. And this is a rather different perspective on the so-called ethical issues of artificial intelligence that are discussed today, but it's nevertheless very important, even if a bit less discussed, at least in the public debate. So let me now clarify from the very beginning that today I will not discuss about so-called existential risks. So these are two examples. I don't know, perhaps you might be familiar with the first one. This was highly had a strong resonance in the public debate on the idea to stop AI research because it might be risky from an existential point of view. The second example is like another example along the same line, the risk of extinction from AI and stuff like this. So here, I will not argue whether these positions are well supported or not. My point is that we have now more concrete risks and we should address them in a decisive way because they are like risk related to algorithmic discrimination, risk related to privacy violations, and also risk related, this is very serious, to the environmental impact that is becoming a huge problem within the context of artificial intelligence. I guess you are familiar with the fact that artificial intelligence models needs, or at least some of them need a lot of energy. So let me now start speaking of risk. I cannot avoid mentioning the artificial intelligence, the EU AI Act. So it's the Artificial Intelligence Act that is the first systematic regulation of artificial intelligence at the European level that has been quite recently approved by the European Parliament. So here you can see that basically the Act is based on different level of regulations for different level of the risk. So you can see that there are unacceptable risks. These are those systems that are prohibited, like, for example, social scoring or some types of facial recognitions. Then we have high risk, limited risk, and minimal risk. So these are quite well-known classifications, both in terms of regulations and in terms of like conceptual elaboration. But in this lecture, I will stress that this is not enough, at least from a conceptual point of view. And why is it not enough? So I want to be very clear. I do think that to have a regulation is super important. It's a very good result. It's, I think it's a milestone at the European level, even if, of course, everybody is aware that this regulation is very complicated, it's difficult, and so on. But here now I will just discuss this from a philosophical point of view, okay? So this is not a criticism of the regulation, but rather is a position arguing that according to this taxonomy, there's no a complete conceptualization of the notion of risk. So I do think that here philosophy is important, has a crucial role, because to clarify concepts, to have a proper conceptualization is a very important point, also to fill in policy vacuums and then impact on regulations. So it is true that the literature usually focuses more on specific AI-related risk, so there is no general approach. Of course, there are exceptions. So let me mention a very nice repository that is the MIT Risk Repository that offers a taxonomy of AI-related risk because it makes a distinction among the entity that causes risk, the intent for which the risk occurs, and also the timing of the risk. So whether the risk is occurring before or after the AI system is deployed. And this taxonomy is also very important because it makes a distinction among 7 different domains, from discrimination to human-computer interactions to safety of the systems and failures and limitations. But yet, and also it creates, or better, it emphasizes the sources and impacts of risk. But yet, from a philosophical point of view, I do believe that it is not enough because there are some elements that are missing also in the attempts, like the MIT Risk Repository, that try to have a more systematic and encompassing view on risks related to AI. So today I want to propose this view to analyze risks in terms of its components. This is very classical in natural risk analysis. So the idea is to apply this multi-component analysis to the case of artificial intelligence and show why this multi-component analysis is important, also in the case of AI-related risk. Also, if, of course, we can have and we can see some limitations, but here limitations should be considered as sort of strengths of this approach because they are a way to just try to solve these limitations. So, first of all, let me define risk. It's difficult because there are many different definitions, and also it's difficult because we have technical and not technical definitions. And also, when we consider only the technical definitions, we have different definitions. Here, I will use the so-called classical approach to the definition of risk, that is the Royal Society approach, so-called a Royal Society approach. That is, risk is the combination of the probability of an unwanted event that might occur and the magnitude of its consequences. Okay, this is very standard. This is the notion of risk that is also used in many different fields. But what is important for me today is that if we adopt this notion of risk and we also look at how risk is defined in the context of natural risk analysis, we see that there are at least 3 different major components of risk, and these components are hazard, exposure, and vulnerability. And I will define them and provide examples of this. So this is what is called the multi-component analysis of risk. And as said, I will adopt this approach that is usually widespread and well-known in natural risk analysis. I will use this in the analysis of risk related to artificial intelligence. What is the point here is exactly to better understand the different factors that can contribute to risk. So let's consider the components of risk and their definitions. So hazard, this is usually what is referred to the source of potential harm, that is, can be both natural and not natural. In the case of natural risk, we have volcanic eruption, but in the case of, for example, a technological risk, we can have data leakage, okay? What is about exposure? Exposure usually refers to what could be harmed, both in terms of living beings and material assets. So you have that in the case of the volcano eruption, people and buildings in the vicinity of a volcano can be exposed to this risk. But also in the case of like technological risk, you have that people using some online services can be exposed to those risks. And then we have vulnerability. Vulnerability refers to the circumstances and measures that make people or assets more or less prone to be damaged. Like, for example, a particularly vulnerable population is like those populations that lives around the volcano. And then, for example, in the case of some technological risks, you have that minors that using some services might be classified as particularly vulnerable. Why is this distinction among hazard, exposure, and vulnerability is important is not just for the conceptual sakeness of the discussion, but because to make the distinction is very important for considering possible measures of mitigations. So let me again go back to hazard. For example, hazard in the sense of natural risk. Basically, we don't have any kind of limitations or any kind of mitigations. So it's impossible to mitigate the volcano eruption or an earthquake. But for example, in the case of technological risk, we can have strong measures of mitigations like prohibition of a service or withdrawal of a technology from the market. What about exposure? Exposure can be reduced both in natural and in technological risk. You can deny access to critical areas in the case of a volcano eruption, or you can impose age restrictions, for example, for some online services. And vulnerability also is important when we discuss about mitigation, because we can have different interventions to reduce vulnerability. You can have, in case of natural risk disaster, evacuation plans or shelters. Or in the case of technological risk, you can have technological tools like antivirus softwares that can be used. Okay? So I hope so far it is clear that at least when we're discussing risk, we have three components: hazards, exposure, and vulnerability. And these three components are important also for measures of mitigation. What about AI? Does it make sense to apply this multi-component analysis of risk for the AI-related risks? And this is a kind of rhetorical question because I will try to show that this is important. We can do this and we have some advantages, both in conceptual terms, but also in terms of mitigations. And this is the paper, if you want to have more details, that we have written to prove and to argue the importance of a multi-component analysis of risk. So let me consider now the first component, hazards. And usually this is the component that we tend to focus on when we discuss about AI-related risks, because we usually consider hazards when we have AI systems that are used in critical contexts, from medical AI systems to systems used in courts or AI systems used in war scenarios. So it's also the situation in which it's very natural to use hazard and to focus on the component of hazards, because AI systems today are increasingly delegated with decisions that have very strong impacts on people's lives. And these impacts can be like because of malfunctions, errors, and this can be like in the case of a wrong diagnosis that can have a very strong impact on people's lives, but also in case in which these are used and without any errors, but still these systems have very strong impacts in the case in which they are used in critical contexts. Let me now add more on exposure and vulnerability, that they are usually not so much debated when considering AI-related risk. So we can say that some systems are critical due to their exposure level. So it means that, for example, let me mention an example. Recommended systems were not classified as high risky in the EU.AI Act at the beginning, in the first versions of the Act. But if we consider the dimension, the component of exposure, they might be classified as highly risky. So they are not high risk if we consider them all in terms of hazard, but they are more risky if we consider that they are have a very high level of exposure. Like, for example, think of recommended systems that are embedded in large online platforms. And probably, I mean, I'm not saying that this is the reason, but probably the idea to move recommended systems to high risk rather than minimal risk or low level risk as at the beginning is a bit along this direction. So if we consider only hazard, recommended systems are not high risk, but if we add the component of exposure, recommended systems, they are high risk, okay? So it's true, I'm aware, it is not a matter of death or life, but here, what is the problem? What is risky is like a risk that might have a very large scale influence in terms of, like, think of cases of privacy, addiction, manipulation, and so on. Let's now move to vulnerability. So vulnerability here, again, if we don't consider vulnerability, we can say that, for example, social robotics or affective computers are not very risky, okay? But these are systems that interact with human users in a very salient, in a very emotionally salient ways. So, and these systems are used increasingly in contexts with high vulnerability, like think the case of elderly care or think the case of education. So again, these systems should be regarded as high risk due to the vulnerability of their users. Okay? So, and this was the first part, the core of my presentation. And the core is that if we consider AI-related risk only as a matter of a hazard, we might miss some important aspects. Instead, if we add the components of exposure and the components of vulnerability, some risks that at the moment, for example, in the AI Act are classified as with limited risk, they increase their level of risk. Okay, so again, perhaps it's not a matter of death or life, but we should regard them as quite critical because they are used, for example, with vulnerable population, or because they are used or they are embedded into systems and platforms whose exposure is very wide. Okay? So, in this sense, to classify risks that is related to artificial intelligence by using the multi-component approach is important. And is important because it conceptualizes risks and the level of risks in different ways. And this is important also for mitigation policies. But now I need to add a second part, because I want to add some peculiarities of artificial intelligence, and I do think that these are important to be considered into this discussion. And we can summarize this question by asking what is so special about AI, and in particular, how this peculiarity of AI is then important for risks. So this is a standard definition of artificial intelligence. You can see intelligent behavior in artifacts. This is another more recent definition, the OECD definition that has been used as an inspiration for the definition of the artificial intelligence in the EU Act. Here you can see that there are common elements, like, for example, AI systems are devoted to solve complex tasks that require adaptation to new environments and new data. They are performed by machines. They are done in an autonomous way. They can produce predictions and decisions. Some of these systems may bring to opacity, but now I want to focus on two elements that are very important and usually not so much debated. Why these two elements? Because they are important for risk. So the first element is that experimental technologies, some AI systems can be labeled as experimental technologies. This is the definition of experimental technologies, and in a very simple way, experimental technologies are those technologies whose risks and benefits are not only hard to estimate, but sometimes are not even known. Okay? For example, nanotechnologies are another example of experimental technologies. So these are technologies characterized by limited operational experience that is not sufficient to assess the risks and benefits. And this is important, for example, if we consider the case of general purpose AI systems, in which they are designed precisely to cover a variety of purposes, from medicine to scientific research to programming to finance. So these are systems in which it's very difficult to identify possible risks before these systems are inserted in their context of use. This is what is called the ex ante analysis. But these also are systems for which it is very difficult to also evaluate ex post possible risks, because these are systems, they are sometimes opaque, or these are systems for which we sometimes lack proper information. And here we also have, I will not discuss about this multi-hazard problem, but it's also true that these systems sometimes can be combined with errors, possible abuses, so we can have a great number of potential hazards. So what is the conclusion here? It is very hard to predict all these risks. And sometimes, again, it's not only a matter of like calculating the probabilities of risk, it's also a matter of that some of these risks are not even known. So here we have to recognize that we have some issues, and that the multi-component analysis of risk that I presented in the first part might be very difficult to be applied, and sometimes it can be also impossible to be applied. We have just seen the case of general purpose AI systems. So does it mean that, okay, we should just renounce to any kind of approach to risk analysis and mitigation? Not at all, of course. We can use this idea, this approach to risk analysis to, for example, consider some areas of concerns and just try to intervene to limit the use of AI systems when we have these areas of concerns. Like, this is a very simple example. For instance, we can say that large language models cannot be used in the context of medical diagnosis because, of course, misdiagnosis can have very fatal consequences. Or we can have approaches that are becoming increasingly common in the discussion today, in which basically there are some limitations to the use of these systems. There are limitations implemented both in the design of the systems, but also in the way they are regulated. Let me mention just a simple example in which basically this was a paper proposing that we should have a legislative mechanism for which, for example, the public release of general purpose generative AI models should be possible only with a reliable tool that can detect that the contents of this model, of these AI systems has been generated by an AI model. I want to discuss the details of this proposal. There are different views, different approaches, also different evaluations. Just to tell you that, again, we have different ways of dealing with risk, even in the case in which we cannot do a proper ex ante and a proper ex post risk analysis. So let me just summarize what we have seen so far, and then I'll move to the last part, which is rather than a systematic reflection on these issues, it's just a way of opening more problems. But what we have seen so far is that a multi-component analysis of risk can be fruitfully applied to AI systems. And it's useful for conceptual clarity, but also for mitigation. But we also have seen that there are cases, in particular, when we deal with experimental systems, in which this kind of approach is very difficult, sometimes even impossible. So we have also seen that, nevertheless, we can have a different approach to risk mitigation, and we can individuate some areas of concerns. And we can do different things when we have individuated these areas of concerns. But we have also admit, and we should be aware, that there are cases in which the assessment of risk is very difficult. So this brings us in the direction of uncertainty. That is a very deep philosophical and mathematical concept. So I will conclude moving in the direction of uncertainty. And to move into this direction, let me mention one of the philosophers that has worked more on the notion of risk and uncertainty, and he uses this tuxedo fallacy. And he says, life is more like an expedition into an unknown jungle than a visit to the casino. Most of the time, we have to deal with dangers without knowing their probabilities. And often, we do not even know what dangers we have ahead of us. I propose to call this the tuxedo fallacy. It consists in treating all decisions as if they took place under epistemic conditions analogous to gambling at the roulette table. And instead, rather than a casino context, also when we consider some of the risks of AI systems, we should rather use the metaphor of the unknown jungle. Why? Because AI systems deal, or some of them deal with some form of uncertainty that cannot be handled by probabilities, or they cannot even be formalized or quantified. And this is what is called severe uncertainty, that basically resists to probabilistic quantification. So what is the point to introduce uncertainty to the discussion of AI-related risk? The point is to emphasize that there are at least two dimensions of uncertainty in the case of AI and in the case of, in particular, some AI systems. The first one is the intrinsic dimension of uncertainty. So some systems operate in very in largely opaque way. We cannot fully predict the outputs. They are very complex technical artifacts, and so it's difficult. It's also difficult for their designers to understand how this system works. But then there is also another dimension of uncertainty. There is the uncertainty in the interaction. And these systems have been designed to interact with humans and societies. But they operate in very complex socio-technical systems in which this interaction is very complex and again, hardly dealt with the traditional tools of probabilities. And it means that for some of these systems, it's very difficult to understand how these systems will work before they will be deployed in their context of use. What is the point here to discuss this? And this is my last point, is that it is important to incorporate also the concept of uncertainty. So in a sense, risk is not enough, and to recognize the intrinsic uncertainty of AI systems. For example, this can be done from a philosophical point of view with the idea of the ethical incrementalism. What is this? It's the idea that AI systems should be gradually and incrementally introduced, at least those systems that are critical under many respects, in order to monitor their social effects, in order to monitor like they are interacting and if they are causing any kind of risk, and in case to step back and improve, for example, the design of these systems. This is, for example, something that is in the EU AI Act, has been suggested as more or less with the regulatory sandboxes. We don't have time to discuss that, but in case. Okay, so conclusions. There's a lot on risks today in artificial intelligence mostly because of the EU AI Act, but not only. And what is missing is a general epistemological framework on the notion of risk. I hope to have shown you that a multi-component analysis of risk, including hazard, exposure, and vulnerability, can be applied to AI system and can be fruitfully applied also in terms of mitigations. But it's also very important to recognize and to be aware that AI systems often generate and operate in context of uncertainty. So we really need novel conceptual framework and also regulatory framework that are able to incorporate uncertainty in a systematic way. So these are some papers and some references if you are interested. So I hope that we still have time for discussion. Thank you.
Okay, thank you so much, Viola. This is very insightful and mind-blowing, so on. So I think that there's time for questions, of course. Um, has anyone some question? Otherwise, I will start. Okay, I can just break the ice and say that, Viola, do you think that uh, somewhat opening the black box of AI can be a way to identify the risks we are going to face, or it doesn't matter. Let's say that researchers and practitioners will be able to understand how AI can predict the following world. Because now the problem is that is so big, the process, that people are not actually able, they can potentially, but they can't in reality, because it's too much of a huge work for understanding the next word that generative AI is predicting. But if they can do that, and yeah, if they can do that, do you think that it will be uh, better to understand the risks, uh, or it doesn't matter opening the black box?
No, it's of course, I do believe that it's very important. It does matter. And also sometimes what I haven't done so far, also in terms of my research with my colleagues, is that sometimes it's also important to better know uh, what is the risk of not doing something. So far, I have focused only on the negative part in terms of, okay, we have systems that can do this and that, but they can be risky, and we should be aware of these risks. I do think that it's also important that we should also be aware, like, what are the risks when we decide not to develop some technologies, for example, or what could be the risk if we could decide not to develop those technologies. So yes, I think it's very important. I mean, it's and sometimes, okay, sometimes we can open the black box, sometimes we can open, but still it's difficult to look inside. But anyway, it's very important. So thank you, Omar, for your question.
Nakano.
Uh,
So I guess
Please, Cynthia,
Cinzia.
go on.
I know
Go on.
Cinzia, I guess if I remember correctly, we were like, when I was a student in philosophy and Cinzia was studying computer engineering, we were like colleagues as students in the course of artificial intelligence by Marco Somalvico.
Yes,
Ciao, Cinzia.
you're right. So it's a pleasure for me to be here today. So thanks for your presentation. Very interesting. I have a technical question, of course, but other, let's say, areas of, let's say, um, exploration. So the technical question is, if you if you think that also the uncertainty related to the AI system is based on the fact that we don't know on which data they rely on. So this is another important aspect, in my point of view, of the results coming from this large model system. So we don't know where they came from and which is the context in the when they are analyzing it. This is the question, and the considerations are related to the risks. So usually the hazardous system, as you of course know, have the human in the loop to mitigate the risks, especially in let's say medicine or law settings. But this is not true when we talk about the risk of vulnerable users. So to mitigate this risk, maybe also an action to educate people on using technology, especially high-risk technology, will be an effort towards.
Yeah. Thank you so much. I will start from the second consideration. I completely agree. Education is very important. And I mean, in terms of risk, but also, again, education is difficult. And it takes time and it takes energy, efforts, also in financial terms. So sometimes, and the very reason why you want to have these like systems into context of vulnerability like elderly care or education is because you want to save money in some sense. So again, it's a matter of trade-offs, but at the same time, we should be aware that, I mean, there are important values, and we should not renounce to these important values, because I think, for example, the case of education, it's like the pillars of our societies. So it's super important. So it's super important, and it's the reason why we should have a very gradual and incremental approach for the introduction of these technologies in these highly vulnerable contexts. And for example, if you think of teachers in schools, they are just left by themselves to deal with the use and the massive use of these technologies by students and by anybody. So education to me is super important. It's really one of the pillars of possible actions. Your first question, of course, I agree. We don't know which data are used and on which data these systems are trained. Sometimes it's not even a matter of data. I mean, also in the traditional, classical, symbolic systems in AI, the point is that they are complex, and sometimes they are even like the composition of different subsystems, and because they are designed precisely to also interact in complex environments. Complexity is there and uncertainty then arises. But then, of course, this is more crucial when we have systems that are trained on thousands, huge and incredibly huge collection of data that we don't know where are coming from.
Thanks.
Yeah, I also have a question, if I can. First of all, thank you very much for the fresh perspective on this. I want to ask a very simple question. Why do you think this approach, like a multi-criteria approach, was not used like in the first place when this AI Act was designed? I mean, this idea of risk, as we've understood today, like this, I would say, three-dimensional, no, as a combination of hazard, exposure, vulnerability, is already well established in other disciplines. So why do you think this was not sort of transferred into this field? Or maybe do you know if this was considered and discarded for some reason?
No, I honestly, I don't know how to answer. But probably, so the AI Act was really an effort, a huge effort in political and technical terms as well. And also was the combination of different views, different compromises, and so on. So I really don't know why. Anyway, it's interesting that many of the steps, anyway, in a sense, were like trying to incorporate notions. Like, for example, another interesting case, it's like the addition of the notion of systemic risk to the AI Act that was added in later versions. And again, systemic risk is something that is in risk analysis is quite common, and at least after the financial crisis in 2008. But I don't know why this was just inserted at the end. It's also because these are so complex processes in which there are so many different stakeholders and compromises that probably this is the reason. And also, perhaps, it's also difficult to have like a very articulated kind of taxonomy, because then it's also important because the regulation is already very difficult. Perhaps the conceptual roots of this regulation should be a bit easier.
Thank you very much.
Okay, then.
I'm sorry.
Oh,
I do have
please,
another one.
go on. Yeah, go on.
No, I think this one idea with which you concluded, this idea of ethical incrementalism, makes just sounds like a proposal of good sense, like very reasonable. How do you see this approach could be sort of introduced or enforced? I don't know if we've seen it even with I don't know, with social media and the challenges that sometimes we have in there is an asymmetry with the company and the end users that were just unfolded 2004, and 20 years later we know all the consequences this is having, especially on vulnerable segments of the population. It's not just socially, even like, I don't know, brain development. We know these implications. So how do you think we can introduce that approach? So having maybe private companies, I don't know, maybe I'm just focusing on an example. I don't know if this is the right thing, but like private companies who have, a right of entrepreneurship, which is a right to some extent, but at the same time avoid this sort of impact. I don't know if the question was clear. It's not clear in my head.
No, it's super clear. And of course, because the problem is huge and very complex. So there's not just one single way of dealing with it. So I do believe that, of course, regulations are super important and we should push a bit in this direction. Education, again, is super important. And also, I would say also the engagement of everybody as citizens. So we can push a little bit in some directions. But then, of course, we need education for doing this. So it's a mix of many different elements, and it's super important. I mean, I have heard a lot about how regulation is a way to stop innovation. That's not true, of course. We have a lot of problems in Europe in terms of innovation, of course, but it's not because of regulation. And then also, we should recognize that innovation is not the only value that we should have as societies. We have many other important values that at least they are on the same level as innovation. So, and we should consider these values well. So it's super difficult, but there are many different elements. It takes time. I agree with you that we should take inspiration from what has gone wrong, for example, in some cases. But sometimes it's difficult, like, for example, social media. But sometimes it's difficult. But anyway, we need to be optimistic.
Yeah, thank you. Thank you very much.
I will send my slides.
Yeah, that's
Okay, sure, definitely.
helpful.
Yes.
Thank you so much, Viola. Okay, if there are no other questions, I'm glad you participated and I'm really happy about this workshop. Thank you so much, Viola, and let's keep in touch.
Okay, thank you very much. Have a good day. Thank you.
Thank you very much
Bye-bye.
again.
Bye.
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 Thank you.
Bye.
Bye.
Bye.